Hello everyone. In this lecture, I shall discuss the game theory, the case of pure strategy, saddle point, Maximin Minimax criterion. So coming to this game theory, it is a part of the operations research. Now it is a question to many of the students. What is the difference between operations research and optimization technique? Now coming to the operations research, it is a framework of analyzing decision making problems, complex decision making problems, right? So operations research is a framework of analyzing complex decision making problems. Okay. But what is optimization? Now optimization techniques are the mathematical techniques or computational techniques to solve these decision making problems, right? Or to be refined, I can say optimization technique is the means to utilize the scarce resources in an efficient manner so as to maximize the profit and minimize the loss. So operation research involves linear programming problem, non-linear programming problem, transportation problem, assignment problem, game theory, job sequencing, okay, and so on, integer programming, linear programming, and so on. Now this present topic is my game theory. Okay, now coming to a game, what do you mean by a game? Every competitive situation is a game, right? Every competitive situation is a game. That means you say, suppose the political campaigns by the political parties during election, right? It is also a your game. Okay, advertisements, okay, by the different farms for different items is also a competitive situation, and it is also a game. So what is a game, right? Every competitive situation is a game. It has the following properties. There are finite number of participants called the players. Each player has a finite number of possible courses of action, rules of the game, strategies, right? All strategies must be known to each participants, but must not know what exactly the strategy will be chosen by the other player. One player cannot know what exactly the other player is going to choose, right? A game is said to be played when each player choose a strategy, right, from the list of strategies available to them. Then the game will play. After all the players have chosen a strategy, their respective gain is finite. The gains of the players depends on their own actions and that of the others. Okay. So before discussing the details of this game theory, let me to introduce myself. Myself, Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. Okay, so without much delay, let me to give you the description of different backgrounds and the terminologies needed in this study of this game theory. Basically, we are dealing with this strategy related games. Okay, while the playing of gambling is not a game here because it is not as strategical based, I will tell you certainly. So let me to explain. So thus my game theory is a mathematical theory that deals with taking decisions in competitive situations, as I told you, political campaigns, advertisement, etc., where there are two or more opposing parties with conflicting interests. Okay, and the action of one depends upon the action of the opponents. Okay, consequently, a competitive situation with finite number of competitors is called the players, is called a competitive game. In competitive game, such as playing of cards, playing of chess, etc., each player adopts a number of choices. Okay, that choice may be finite or infinite. In fact, we are dealing with the finite case called the strategies. Different strategies adopted by players determine the respective outcomes. Okay, respective outcomes. I will tell shortly the details, which may be positive, the outcome may be positive, the outcome may be negative, the outcome may be 0. 0 will indicate the draw. Right? That means when player A choose one strategy and player B choose another strategy. So after the strategy is being chosen, an outcome will come out. That outcome may be a positive outcome, that may be a gain, that may be a loss, or that may be a draw. Right? So as I am talking about, we are basically deal with the study of the games of strategy. Okay. So here the gambling is not a game of the strategy. Right? As the player playing such games simply beating against the others. Okay. So we basically deal with the games of the strategy. Now come to some basic definitions and terminologies. Now coming to a two-person zero-sum game, right? A game is said to be a two-person zero-sum game if there are two players. Okay, exactly two players, and the net outcome is 0 out of the playing of the game. Okay, so let me write a game with only two players is said to be a two-person zero-sum game if the loss of one player is equal to the gain of other player, such that the net gain is equal to 0. Is here 0. Right? Suppose there are two players. Okay. Suppose there are two players, A and B. A is having M strategy. And B is having N strategy. Then the game, it is a rectangular matrix. The game is represented by a rectangular. The game is described by a M cross N matrix. Right, as follows. That means the matrix is like this. The game is described by the M cross N rectangular matrix as follows. So here player A having the strategies A1, A2 up to M number of strategies. So AM, and player B is having the strategies B1, B2, so on up to Bn. So this is my M by N matrix now. So while player A choose A1, B choose B1, the outcome here is here A11. Likewise it is A12, A1n, and A21, A22, A2n, and likewise it is AM1, AM2, AMN. So this is a payoff matrix. Now this payoff, now what is the point of view of A and what is the point of view of B, we will discuss. Now AIJ means what? AIJ means what? Payoff to player A. Okay, payoff to player A. When A choose ith strategy and B choose jth strategy. For ith strategy of A and jth strategy of B. Okay. Now basically this is the payoff for player A. Payoff matrix for player A. So basically the player written in the left hand side here, this payoff matrix is given by convention. So basically the payoff matrix here, what is the player, what is being written in the left hand side, this is the payoff matrix for that player. Okay, so the payoff matrix for player whose strategy is displayed on the left hand side is given, right? So now what is the objective of A? Objective of A is to maximize the profit. to maximize the gain. Maximize the gain. In particular, player B is not going to be silent. Maximize the minimum profit. Maximize minimum profit against B. That's why it is called the Maximin value. Okay, Maximin value, right? Maximin value. And what is the objective of B? Objective of B, basically what is being written here, right? So it is the loser side, say, so by convention. Okay, objective of B is to minimize the loss, right? To minimize the loss. That means against what? A. So in particular, it is the minimize the maximum loss. Minimize, right? Maximum loss. Right? So we call it Minimax value. In point of view of B, it is Minimax value. Right? Right. From the point of view of A, we are talking about the Maximin value, right? And it is my Minimax value. So let me to write the objective in details. So as I have told you, so after the game is being played, this is the outcome, and we have to solve the game, right? We have to solve the game. So from the given payoff, we understand this is the payoff for the player which is written at the left hand side. Now the player in the left hand side, the objective is to maximize the minimum profit. So we find row minima. Here, row minima. After finding row minima, we then maximize it. And it is against the player B. And from B's point of view, we have the minimize the maximum loss. Means we find the column maxima. After finding column maxima in each column, we just minimize it. Okay, right? So it is against player A. That is to find the minimax value. Now what is Aij? So this Aij, suppose this means when player A choose A1, player B choose B2, then this A12 is the profit of your A, right? And at the same time, this A12 is the loss of your player B. So that means I can say the Aij means the payoff to player A if A chooses the ith strategy and B chooses the jth strategy. Okay, so note that profit of Aij, player A, is loss of player B. Note that profit of player A is equal to loss of player B. If Aij is suppose my 5, I say profit of A is 5 unit, and loss of B is 5 unit. If I say, which is same thing as what is profit of B is minus 5 unit. Now if you add them, what is the net profit? Net profit is equal to 0, right? So as a result, if I take the payoff matrix in view of player A, then in the same way the payoff matrix for the player B simply the negative of the elements, so that if you find the sum of these two matrices, this will 0, right? So that's why it is the net profit is 0. So now coming to what do you mean by the solution of a game or the value of the game? Okay, by solving a game, this is out of the given payoff. A payoff is given like this from a given payoff. Okay, from a given payoff matrix, we mean to find the optimal strategy strategy or strategies, okay, that maximize the gain of A, or in particular we can say Maximin value of A, Maximin value of A, right? We find row minima, then we maximize it, value of A, and at the same time minimize the loss of player B. And exactly what does it mean? Minimax value for B, minimax value of B. That means we find the column maxima, okay, then we minimize it, right? Then we minimize it. So now coming to the value of the game, right? So solution of the game means we find the optimal strategy, right? That means which strategy of A will be chosen and which strategy of B will be chosen, that will keep the player A and player B in most profitable position, right? That means player A will maximize the gain, player B will minimize the loss, right? So accordingly, if I solve one example, then your idea will clear. Now coming to the value of the game, the value of the game is defined as the maximum gain guaranteed to player A, or the minimum loss to the player B, when both the players use their best strategy. Best means I mean to say optimal strategies, right? When player A chooses optimal strategy, suppose the optimal strategy for player A is my B2 and for player A is my A2, then this will be the value of the game. If this is the best strategy for B, this is the best strategy for A, then the corresponding payoff is the value of the game. So once solving an example, this idea will clear, okay? Now coming to one more thing, what is a pure and mixed strategy? So now coming to the definition of pure and mixed strategy, okay, as I've already told you earlier, strategy is a predetermined procedure. It is already known before the start of the game, okay? So there are two types of strategies. One is pure strategy and other one is the mixed strategy. The pure strategy means pure strategies are chosen from the strategy available to player before the game. Okay, that means exactly you choose a particular strategy of this or one or more strategy. Exactly you choose either B1 or B2 or simultaneously, or exactly A2 or A3. Means the exact strategy will be chosen. And mixed strategy is the probabilistic case. Suppose I say half of A1 and half of A2, or 1/3 of B1, 2/3 of B2, so that the sum of the probability is 1. So that means here pure strategy is chosen from the strategies to the player before the start. I have already told you that once each player choose a strategy, then the game is set to be played. So similarly, for mixed strategy is the combined case, right? Mixed strategy is chosen by using a probability distribution of the strategies available to player before the start of the game, because we can say it is not exactly the strategy, it is the part of the strategy. 1/3 of A1, 2/3 of A2, 1/3 of A1, 1/3 of A2, 1/3 of A5, means the sum of the probability is 1. Likewise we have to choose. So in this lecture we will discuss the pure strategy case, and the solution to the problem is based on the Maximin and Minimax criteria. So let me to write that. So now coming to the Maximin and Minimax principle. Basically this principle used to solve the problem for pure strategy case and saddle point or equilibrium point. So this principle states that if Maximin value equals to minimax value, then the game is said to have a saddle point or equilibrium point. And the corresponding strategies are called optimum strategies. The amount of payoff at the equilibrium point, at the saddle point, is the value of the game. Okay, is the value of the game, right? So while we write the principle, we write up to this principle states that if the maximum value equal to the minimax value, right, then the point is, then the game is said to have a saddle point. Okay, and corresponding to the saddle point, the strategies are called the optimal strategies. For example, suppose this is my saddle point, then the corresponding strategy, this is the best strategy for B and this is the best strategy for A, right? Similarly, the more than one best strategy may be there. So now the rule to determine the saddle point, right? So in each row we find the row minima. Select the minimum element in each row. Mark them, suppose you say star, mark them star. Okay, then you select the maxima element in each column. Select the maxima element in each column, and mark them, you say suppose plus, you mark them plus. Then finally, if there exists an element with marked with both plus and star, if there exists an element marked with both star and plus, then this element is the saddle point. Okay, saddle point. So if you solve one example, then this idea will clear. Now in view of the above rule, and while we solve the problem, we should focus on the following remarks. Okay, so once we find the saddle point, the corresponding strategies are the optimal strategy for the players. If maximum value is equal to the minimax value, right, then that point is my saddle point. In this case, we say the game is strictly determinable, right? Now if this minimax value and maximum value is equal to 0, if they are equal, then determinable. If again it is 0, then it is fair, right? Determinable and fair. If once 0, then fair. Okay, if they are equal, then determinable, and they are equal and 0, then it is fair. Now if the maximum value is not equal to minimax value, then there is no saddle point, means there is no is not equal to 0. Yes, if maximum value equal to minimax value but not equal to 0, since this and this are equal, so it is determinable. Since not equal to 0, so not fair. Now once this maximum value is not equal to minimax value, then there is no saddle point. That means there is no pure strategy. We have to think of the mixed strategy case under probability distribution. Now what are the rules for 2% zero sum game? As we discussed, only 2 players can take part. Each player has finite number of strategy. Each specific strategy results in a payoff. The total payoff, the payoff to the players at the end of the game is 0. Right? In view of this, I can say, suppose this is the payoff for A, 2, 3, 5, 4. That means this is the gain of A. In view of B, I can say minus 2, minus 3. Suppose it is minus 5, then it is plus 5 and 4. Right. Now in view of this is from the point of view of A. From A point of view, which is equivalent to B's point of view. B's point of view. Right. Then if I add these two, then we will have the net gain is 0. Right. The net gain is 0. Now coming to one example, then your entire discussion and idea will clear. Solve the following game. This given payoff is given. You are asked solve the game. Solve the game means we have to find what is the value of the game, what is the value of the game, and we have to find the optimal strategy. Okay. So solve the game means we have to do these two things. And next we have to determine whether it is determinable, means maximum value equal to minimax value. Then determinable. Fair means if it is again equal to 0, then fair. Now we have to find the gain of A and gain of B. So let me to solve it. The solution of the problem, you see, these are the for player A and these are for my player B. Player A is having strategy A1, A2, A3. Now this is the payoff matrix. Now we have to find, this is my player A, this is my player A and this is my player B. Now I have to find the row minima. Okay, I have to find the row minima here. Row minima from A's point of view. So row minima in this row is my minus 2. As I have told you, I should mark it star. I should mark it star. And in this row, the row minima is minus 6. I should mark it star. And the row minima is here minus 8. I should mark it star here, minus 8. So this is from A's point of view, right? Now from this is my player B. This is my player B. Now from B's point of view, I have to determine the column maxima. What is the column maxima in this row? The column maxima is this, so I mark it plus. And the column maxima in this row is 20, I mark it plus. The column maxima in this row is 2, I mark it plus. Right, is minus 2 here. Right, then from A's point of view, we have to find, actually this is the saddle point and these two saddle points are available here. Okay, now from the A's point of view, I have to find maximum of all these minima. Okay, I have Maximin value means I have to find the maximum of these three, minus 2, minus 6, minus 8, and it is obviously my minus 2. Right, and from my B's point of view, I have to find the minimax value. Right, I have to find the minimax value. That means the minimum among all these maxima, minimum of your minus 2, 20 and minus 2. It is of course your minus 2. So here this minus 2 means this is my saddle point. Okay, so I can denote it my V bar here and I can denote it my V upper bar. Okay, so now we see that this thing is not necessary to write in the right hand side, means for such question point of view, already this point where both star and plus are marked, this is my answer. Now what is my saddle point now? So clearly Maximin value, right? Maximin is equal to minimax is equal to 2, right? So therefore the saddle point is the value of the game, which is the saddle point, right? So now what is the value of the game? Value of the game is equal to 2. And what is the best strategy? For A you see, you have only A1. This is my A1, A2 and A3. And for B you see, this is your B1, this is your B2, this is your B3. For B there are two strategies best. The best strategy for A is A1 because the saddle point corresponding to row 1. And for the best strategy for B is my both B1 and B3. Right? Once it is asked that solve means, for solve it's fine, then we close it. Now next, for the next it is asked whether the game is determinable, whether the game is determinable and fair. The game is not fair, it is determinable. Once there is a saddle point means it is determinable. Yes, yes, the game is determinable. Game is determinable, but not fair. But not fair. Not fair. Determinable. Why it is determinable? Because V bar is equal to V bar is minus 2. Okay. Maximin is equal to minimax. Why it is not fair? Is here V. Why it is not fair? Because V is not equal to 0. So it is not fair. Is it a 2% zero sum game? Yes. It is a 2% zero sum game. Yes, the game is determinable. Then is the game fair? But it is not fair. The next question is, what is the gain of A? You see here. You see here. This is minus 2. Right. So that means the gain of A is my minus 2 here. Right. So this payoff is given in the point of view of A. So the gain of A is next. The gain of A is equal to minus 2. What is the loss of B? Loss of B is gain of A is minus 2. If I ask you, what is the gain of B? What is the gain of B? Gain of B is my reverse of this. Okay, plus 2. Such that this net gain, right? Net gain is here 0. Net gain is here 0. Right? Coming to one short question. Solve the following game. So solve the following game means you see here row minima is here 5, I mark it star. Row minima is 4, I mark it star. Then what is my column maxima? Column maxima, just 1 second. So here column maxima is here, this 5 is the column maxima, and here the column maxima is 7. So this point is the saddle point. Okay. So by solving the game, so my value of the game V is equal to 5, and optimal strategy for A. So this row, corresponding row is A1, and for B is, it is your B1. Okay. So for that question. Now comes to another important question. Determine the unknown P and Q such that A22 is a saddle point. Okay. A22 means this is a saddle point. Right. So we have to solve it. Consider 2, 4, 7, 10, 7 Q, 4 P, 8. Okay. So ignore P and Q, we compute Maximin and Minimax value. Minimax value. As you see here, what is the Maximin row minima here? Here row minima is 2 here. I mark it star. Row minima is 7 here. I mark it star. Row minima is 4 here. I mark it star. Then what is my column maxima? Then my column maxima. My column maxima is in this row. The column maxima is this column maxima. I mark it plus is your 10, right? And I mark it plus, it is your 7. I mark it column maxima is 8. It is your 8. Okay. So this A2 this 7 A22 is my saddle point. Okay. Now what is my this is Maximin value, right? V bar lower bar is equal to your 2. And what is your Minimax value? Here Minimax value is V over bar is equal to, sorry, it is your 7. It is also your 7 here. Now what is the value of P and what is the value of Q? You see here P is in the second row, second column, right? What about P? For P you see this P is here. We have taken the column maxima is 7. The column maxima is 7 here, right? In view of B, the column maxima is 7. So P cannot be greater than 7, right? So P should be less than is equal to 7. Now you see in view of your Q, right? So Q, you see here in view of this row here, right? In view of this row here, we have taken the row minima is 7 here, right? Row minima is 7 here. You see this row. So Q should be, right? So Q cannot be smaller than 7. Q is greater than equal to 7, right? Q is greater than is equal to 7, right? Because from this point of view, we search this row, we see this row, and we see this column and we see this row. From this point of view, we have taken the column maxima here, right? Since 7 we have taken the maxima, P cannot be superior to 7. So P less than 7. Now from this row point of view, 7 is the row minima. So Q cannot be more than that. So Q should be, Q cannot be small than that. So Q should be greater than equal to 7. Now coming to one more question. So now coming to one more important question. For what value of lambda the game is strictly determinable? You see, we find the row minima here. Row minima here. We mark it. We ignore your lambda. Okay. So row minima is my this. And row minima here is my minus 7. And row minima here is my minus 2. And coming to your column maxima here, in this row the column maxima is this plus. In this column here, column max is here minus 1 here, okay, and the column max is here 6 here, and the column max is here 2 here, okay, column max is here 2 here. The row minima value here is, row minima is 2, this is minus 7, this is your minus 2, okay. So what is your minimax Maximin value? Maximin value is your 2, right? This is your 2. And what is your minimax value? So minimum among these 3 is your minus 1, right? So this is V over bar. Now the game is strictly determinable. The game is strictly determinable if your minimax less than equal to lambda less than is equal to maximin, okay. So your minimax value here is your minus 1 less than is equal to lambda and less than is equal to your 2, right? You can try any value here and you can try any value and you see that this game is strictly determinable, okay. So the video is getting lengthy, we should close this video. Before that I should summarize. So let me to summarize. As I have told you, every competitive situation is a game, okay. In this lecture we have studied the game with strategies, right? And the rules of the game is known. Basically we have discussed the 2-person game, okay. There are 2 participants involved in this game, and by solving a game we mean to find the saddle point, the Maximin value and minimax value. Here generally the payoff is written in view of the gain of the player A. The player what is being written in the left hand side, by convention this is the payoff is written from his basis, okay. And accordingly if you think of its opponent, then just the elements will be simply the negative. Then this will be the payoff in view of the opponent player for his gain, okay. So that the net gain is 0. That's why it is called a once this net gain is 0, it is called a 2-person zero-sum game, okay. So now for we have to find the Maximin value and minimax value, and if this value coincides then it is a saddle point, and the corresponding strategies are the pure strategies. If minimax value is not equal to Maximin value, that means if there is no saddle point, then there is no pure strategy. We have to think of the probabilistic case of mixed strategy. We will discuss it in the subsequent lecture. In the next lecture I will discuss. So up to this, my appeal to you, if you feel this lecture is interesting and helpful, please like and subscribe to this channel, which will boost my motivation so that I can create and upload the future videos for your benefits, okay. So with this I should close this lecture here. Thank you all. Have a nice day.